Have you ever wondered if it's possible to actually see an atom? Like, with your own eyes. Not through a microscope or computer render. I mean you right now, using just your senses. It sounds like science fiction, or maybe even clickbait, but today I want to show you why it's not as crazy as it sounds. Because the truth is, you've probably already seen something that was shaped by atoms, not one atom, but entire structures of them. And with a little science magic, you can actually see the fingerprints of atoms from your living room. Let's start with what makes this so incredible in the first place. Atoms are ridiculously small. To give you some sense of scale, if you took a single human hair and split it lengthwise about 1,000,000 times, you'd get something around the width of a single atom. Most atoms are about 0.1 nanometers across, and to make things worse, they don't even reflect light the way larger objects do. Visible light, the kind our eyes can detect, has a wavelength that's much too large to bounce off individual atoms in a meaningful way. So even with the best optical microscopes, atoms remain invisible. In fact, when you try to look at things that small using visible light, it's like trying to read a book by throwing basketballs at it. You just don't have the resolution. But here's the twist. Even if you can't see individual atoms directly, you can see their influence. You can see the way they line up, how they diffract light, and how their patterns shape the world around us. Especially in materials where atoms are arranged in neat, repeating rows. These are called crystals. And crystals are kind of like nature's way of showing off atomic order, at a scale we can almost perceive. Let's take an example that might already be in your pocket. CDs and DVDs have tiny grooves etched into them. These grooves are on the scale of hundreds of nanometers apart, just big enough to bend light. When light hits these grooves, it gets split into a rainbow depending on the angle. A phenomenon called diffraction. That rainbow shimmer you see on a CD? That's the same principle that allows scientists to detect atomic arrangements. When atoms are aligned in a regular pattern, like in a crystal, they can diffract light in similar ways. Only the spacings are smaller, and we usually have to use X-rays instead of visible light. But sometimes, with special materials, the spacing is just large enough that visible light gets diffracted in a way that we can see. And that's where your eyes come in. One of the coolest examples is opal, the gemstone. Opals have a structure made of tiny silica spheres arranged in a near-perfect lattice. Kind of like atoms in a crystal. The spheres are about 200 to 300 nanometers in diameter, just right to diffract visible light. That dazzling play of color in opal isn't from any pigment. It's from light being bent and scattered by that tiny, regular structure. So, in a very real sense, when you look at an opal, you're seeing the effects of ordered matter on a near-atomic scale. You're seeing how the structure of material at the nanoscale, made up of millions of atoms in precise arrangement, can interact with light in ways that are visible to your naked eye. Another example is metal. If you've ever looked at polished steel, not the shiny chrome stuff, but the etched surface of a knife or a piece of carbon steel, you might have noticed these grainy patches, almost like topographic patterns. Those grains are regions where the atoms are aligned in a specific orientation. Each grain is like a little neighborhood where atoms all face the same direction. The boundaries between them? That's where things shift. Where atoms don't align quite perfectly. Those boundaries reflect light differently, and that difference is what your eyes are picking up. Again, you're not seeing individual atoms, but you are seeing the boundaries between atomic structures. That's kind of incredible. But it gets even cooler. Under certain conditions, you can use thermal processes to make atoms visible on a surface. For example, when a metal surface is heated and cooled carefully, the atoms have time to rearrange into crystalline patterns. Scientists can then polish and etch that surface, revealing the grains and dislocations, which are direct results of atomic motion and structure. These images aren't taken with some billion-dollar collider. They're sometimes made with simple lab tools and observed with visible light. So again, we're not seeing atoms in isolation, but we're seeing their arrangement, their organization, and their collective influence. And here's something fun you can try at home. Take a really pure crystal, like table salt or sugar, and place it under a microscope with polarized light. What you'll see are beautiful, intricate patterns and colors. This is called birefringence, and it happens because the internal atomic structure of the crystal bends light in different directions. That internal atomic symmetry, something completely invisible under normal conditions, suddenly reveals itself through a dance of light and shadow. And you're watching it happen with your own eyes. So let's step back a second. Can you see an atom all by itself? Number not yet, and not with just your eyes. But can you see the results of atoms? The arrangements they make? The ways they bend light, create colors, and reflect structure into the macroscopic world? Absolutely. In fact, you already do. Every time you look at a shimmer in a butterfly's wing, or the rainbow in a CD, or the shimmer of a gemstone, you're seeing the shadows of atomic order. You're witnessing matter's internal scaffolding made visible. And I think that's kind of beautiful. We often imagine the atomic world as something hidden away, locked behind expensive machines and deep inside the realm of physicists. But the truth is, it's right in front of us all the time. In every sparkle, in every glint, in every rainbow ripple that dances off a soap bubble. The atomic world isn't invisible. You just have to know how to look. So the next time someone says, you can't see atoms, just smile. Because while it's technically true, it's also deeply misleading. With a bit of science, a little curiosity, and the right kind of light, you've been seeing the effects of atoms your entire life. And if that blew your mind just a little bit, go ahead and hit like. Maybe share this with a curious friend, and definitely subscribe. Because there's a whole invisible universe out there, and we're just getting started.